something, this is processed in your nervous system. So from peripheral to the central nervous system. Okay? So briefly recalling how neurotransmission works. So this does not have any sound. So this is the presynaptic nerve terminal, remember? So you have the synaptic left, the postsynaptic cell surface, and then what? You have your calcium channels, remember? The sodium channels at the postsynaptic terminal. So you have your neurotransmitter vesicles. Now, calcium is responsible for attracting your transmitters to the surface, which will attach to your receptors. So whether it's cholinergic, adrenergic receptors, calcium, sodium influx, again, and then the change in the membrane permeability, right? So what are the three phases? So you have the depolarized state, then it repolarized na until it relaxed. Okay? Now, let us move on. You have different types of sensory receptors. Can you guess what are they? Lucerni-Lepon. What are the types of sensory receptors do you know? Okay, what else? Chemo. Okay. Okay, very good. So you have mechanoreceptors that detects deformation. Okay? So when you have pressure on your skin, when you touch an object is touched on your skin, so your mechanoreceptors respond. What do you call that detects changes in temperature? Thermoreceptors, the cold and the warm. What about that brings about damage? Nociceptors. Okay, that is for pain. And that detects light, electromagnetic receptors. Okay, in your eyes. And for taste, smell, chemoreceptors. So that is how it works. So this is supposed to move, but unfortunately I can't find the real. Anyway, when an object compresses on your skin, the mechanoreceptors are stimulated such that you are able to feel that sensation. Okay? So each of the principal types of sensation, the touch, pain, sight, and sound is called, when they are different, what do you call that term? Blank of sensation. The modality of sensation. And because each receptor is responsive to only one type of stimulus, then we have what we call specificity. Na? There is a coding mechanism, and you call that the labeled line principle. Okay? So how the sensation is perceived is determined by the characteristics of the receptor and the central connections of the axon connected to the receptor. Okay? So these are the types of receptors. And the mechanisms, so we have discussed earlier, mechanical deformation. So you have to recall what happens when there are any stimulus. There will be membrane depolarization, opening of the ion. Even application of chemicals will open an ion. Change in temperature will also alter permeability of the membrane, and even electromagnetic radiation that changes membrane characteristics. Again, recalling, a membrane is negatively charged inside under at rest. When you have a stimulus there, when it sends a stimulus, what happens, it will deform the area and produce a receptor potential. When that potential is great enough that when it is above the threshold, then an action potential occurs, right? So I hope you still remember that. So you have excitation, above the threshold, then it becomes action potential. Here, this was our illustration then. So resting membrane potential, so there is a threshold. Above the threshold is the receptor potential. When it is great enough, then an action potential can occur. Okay? Now, what is the term when a continuous stimulus is applied? The receptors respond rapidly at first, but response declines until all receptors stop firing. Any guess? So initially, when you enter the room, a dark room, you cannot see anything, then eventually you adapt. Adaptation of receptors, right? So your receptors can adapt. Even the sight, the sound, and even the smell. Those receptors can respond, especially movement. So when that stimulus is applied, what happens initially, there will be a rapid response, but eventually it will decline until it stops firing. As I said, a very good example is when you enter a movie theater. Initially, you cannot see anything, then because of the adaptation and everything, then light now comes in. Okay? What else? Example, your clothing. Initially, you will feel it, but eventually, your receptors will be adapted that you have your uniform on you. When you put on a jacket, initially, you felt the jacket, which is heavier than your uniform, but eventually, will not feel it anymore. Okay? So these are the receptors that adapts. Photoreceptors, mechanoreceptors. Okay? But some will adapt slowly and some will adapt rapidly. So it depends. So we will discuss later the slowly adapting and the fast adapting receptors. So when it is slowly adapting, it continues to transmit impulses to the brain for long periods of time while the stimulus is present, and then you keep the brain apprised of the status of the body with respect to its surroundings. So what happens? Eventually, when it has adapted, as long as the stimulus is present, this may take hours or days. That's why it's slowly adapting. And an example would be the muscle spindle, the Golgi tendon organ, Ruffini's, chemo, and baroreceptors. So these are the slowly adapting receptors, or the tonic. Now we have the phasic, or the rapidly adapting. This only takes, respond only when change is taking place. So a very good example is balance and movement. When you are blindfolded, you suddenly tip on a stone, then you balance yourself. But if it's not there, then there will be no response that will take place. Example would be when you ride, on a vehicle, when you are on a zigzag road, you are able to anticipate whether you're supposed to move this way or that way to balance. So the receptors are in your Pacinian corpuscle or in your semicircular canal. Okay? So these are the rapidly adapting or phasic type of receptors. Now, important for you to know, so this is a must know, that you know the general classification of nerve fibers. Are you aware of the general classification of the nerve fibers? The A and the C. The A is myelinated and the C are unmyelinated. And what is the myelin shift for? For faster conduction, saltatory. Remember? Because there will be rapid exchange of your ions on that area. The A is divided into alpha, beta, So this is how they are classified. So actually, you also have the 1, 2, 3, 4, 1A, 1B. Na? For muscle spindle, look here. Na? The primary, secondary ending, which type of nerve fibers are they? A alpha, A delta. The hair receptors, deep pressure, and you can see here pain. It can be subserved by both A delta for pricking pain and C for aching pain. Crude touch and pressure, tickle, cold and warm are also through your type C nerve fibers. And remember that type C are unmyelinated, meaning they are a slow conducting nerve fiber. Okay? How do we feel this stimulus? So there are different mechanisms how they work on or how are they going to stimulate the receptors. So there are certain things that can happen. So because the signal intensity is very critical for the interpretation of the signal by the brain. So it depends on the signal intensity. And it can be achieved by two mechanisms. Either you increase the number of fibers stimulated, if that stimulus will increase the number of fibers, and you call that spatial summation, or whether there will be an increase in the rate of firing of a limited number of fibers, then that is called temporal summation. So always remember, so critical for the interpretation of the signal is the signal intensity. And the signal intensity can be increased by increasing the number of fibers through spatial summation and increasing the rate of firing through your temporal summation. In illustration, this is how it looks like. If there's only one or a very few fiber, there will be very weak stimulus. If there are more fibers, moderate, and of course a strong stimulus, even with an increasing number of fibers, that will be stimulated, then that is how you perceive the signal. So that signal is relayed through your neuronal pool. Remember, what are the parts of your neuron? What is this? Axon. This is your cell body and your dendrites. So which receives information? Dendrites. Okay? So dendrites then process through the neuron, goes to the axon, and then goes to the terminal. Remember the video presented earlier was a terminal, an axon terminal. It will then attach to the next, which is a synapse. Okay? So you have different zones. You have the discharge or the excited zone, or maybe the facilitated zone. So more signals will occur at this level, from the input to the output nerve fiber. Okay? Again, there are special characteristics of neuronal, and there are different types of circuits, which you have to remember as well. The converging, diverging, and the reverberating. So just like the movie, Divergence. So when weak signals enter a neuronal pool to excite a far greater number of fibers leaving the pool, this is called divergence. Again, weak signals enter a neuronal pool to excite far greater number of nerve fibers. You call that divergence. Okay? And there are two types of divergence. One is the amplifying, meaning the input signal spreads to increasing number of neurons as it passes through successive orders. Whereas, the other type is divergence into multiple tracks. Signal is transmitted in two different directions. So this is divergence by amplifying. So from one signal, it involves two different neuronal pools as it goes through the different levels of the neurons. Whereas the divergence into multiple tracts, then it goes. So this one is an example of the skeletal muscle pathway, the corticospinal. Whereas this one, this is an example of the one that is happening in the, when you have signals from the spinal cord, some will go directly to the thalamus, some will go to the brainstem, some into the cerebellum. So that signal means through divergence amplifying into different tracts. No? Because you have to react or move in such a way that all this thing has to be processed. No? Not only on one endpoint. What about if you have from multiple inputs uniting into excite a single neuron? Convergence. Okay? So just like this one. So it could be from a single source or from multiple sources. Okay? So that is this now, this on the other hand, this mechanism is important for functions of the central nervous system when you correlate, na? When you summate, or when you sort different types of information. Just like what we're having now. You have now chemoreceptors, mechanoreceptors, thermoreceptors. You now have divergence, convergence. So how are you going to sort all those information in your brain? So this neuronal pool of summation can help us in that way. Now, an impulse will not just be one way or one pathway. It could be on several ways. Now, it will not always be excitatory. It should also have its control on inhibitory. Otherwise, if it's purely an excitation, then you'll go into fatigue. You will not be able to re-energize. That's why in the same nerve fiber wherein an excitatory stimulus, of course, somehow there will be an stimulation of the inhibitory response so that there will be no fatigue. No? So you have to rest for a while. In such a way that when you're listening to lectures, initially you're awake, slowly, eventually, you can grasp and listen only for a few minutes, right? You can only concentrate on a few minutes at a given time. You cannot concentrate the entire lecture of 1 or 2 hours. It's because it's not only the excitatory that works, sometimes the inhibitory overpowers the excitatory. No? So that's why I don't want to lecture so many long lectures. It's your responsibility to read as well. Okay, so we have initially the input to output, one mechanism. Then you have the input. You have facilitated stimulus so that the output would even be greater. And we said that there could be facilitation and inhibition at the same time. And there will be also mechanisms wherein there will be reverberation of the circuits. Na? This is the mechanism of a positive feedback. Na? That when a neuronal circuit feeds back to re-excite the input of the same circuit. So once stimulated, it repeatedly discharged for a long time. Seizures can be one. Na? Seizure disorders. So there will be reverberation. If, of course, it has to be stopped. But however, sometimes it doesn't. Okay. So that is the last slide for chapter 46. Any questions? Ilang minutes ako? 10 minutes? 20? So let us move on to chapter